All right, this is 13.6. We are solving radical equations. What do we do first when we have rad 2x plus 3 equals x? Jaden?
You're going to square both sides.
Square both sides. And then we get?
X squared equals 2x plus 3.
Can we read from left to right?
Okay, sorry. 2x plus 3 equals x squared.
Good. 2x plus 3 equals x squared. Next step.
You're going to subtract from the left side because you don't want x squared to be a negative number.
Set it all equal to 0. Subtract the 2x, subtract the 3. You can do it all at once. And now I'm going to factor. What multiplies to negative 3 and adds to negative 2?
Negative 3.
Okay. What adds to negative 3, multiplies to negative 3, Sebastian?
Negative 3.
Negative 3 and 1. Okay, so my answers are x plus 1, x minus 3, and what would the solutions be to that? Sydney?
X equals 3 and x equals -1.
Perfect. And do they both work? That's the thing to remember here with these radical equations. You've got to check your solutions in. So I'm going to try negative 1. 2 times negative 1 is 2. Negative 2 plus 3 is 1. Are these equivalent? So it's not a solution. When I try 3, 6 plus 3 is 9. What's the square root of 9?
3.
That works. So that is our solution. Are you guys remembering this? So you got to remember to check. You got to remember that when we square, we don't take an absolute value. It's when we root that we take an absolute value. Yes?
Is it possible to have both be extraneous?
I think so. I think I've had that situation. Okay. Because it's possible to have a no solution. Right? Well, it's a tough one. All right. Rad 2x. Do you guys want to try this one on your own?
Yeah.
What's different about this one?
Plus 6.
It has a binomial on the right. So when you square it, you have to square the binomial. Okay, pause the recording and try this problem on your own. Hear from people I haven't heard, like Michael. Yep. Good. Nathan, next step.
For the next step, then you would want to get all of the x's on one side, so you would subtract the 12x.
Am I subtracting what?
You're subtracting your x squared plus 12x.
Okay. We always, the side we move it to,
Oh, yeah, you add it, because you want the root to be positive.
okay, we want this quadratic to be positive. So what am I doing?
So with that, then you just subtract 2x from the
And?
and 15.
Good. We're subtracting both 2x and 15 to both sides. And then we have what multiplies to 21 and adds to 10. Hannah?
7 and 3.
7 and 3. X equals negative 3 and negative 7. Now, as we try them, which solution works? Sarah? Negative 3. When I substitute it in, it works. When I have negative 7, it does not work. So negative 7 is extraneous. Okay, what would we do next? On this next problem, Harry. Not yet. We don't do that. Keep going, Harry. Clarify. Subtract 2. Get the root by itself. So now I've got x minus 2 equals rad x plus 4. What are we going to do?
And then you square it.
We square both sides. And we get Good. Okay, next step, Jaden.
You want to subtract x from the right and the left, and you also want to subtract 4.
Good. Subtract both. And then, last step, Jaden.
Oh, you can factor out next and get x times the quantity of x minus 5 equals to 0, and then x is equal to 0 or x is equal to
Right, set them both equal to 0. We factor, set them both equal to 0, and we get 0 and 5. What must we do with radicals? Check for extraneous solutions. Substitute the 0 back in. Does it work? No, it doesn't. Because it becomes 2 plus the square root of 4 is 2. 0 does not equal 4. So 0 doesn't work. Okay, questions there? Yes.
Wait, wouldn't 0 work? Because if you were to subtract 2 from each side, then you would get.
It would be negative 2 does not equal positive 2. Okay, yes, Jaden.
Is it possible to have 2 extraneous solutions?
We just asked that. Let's keep going. Okay, next part of this is going to be the I want you to come up with that answer. You can go Google that. Okay, transforming formulas. So y equals ax squared. And remember the semicolon really means solve for the x. So the second part of this lesson, we're just trying to get that x alone. So what would I do to y equals ax squared? Caitlin. Good. And you're writing as we go, not waiting till the end, because I'm not going to keep it up there. So we're dividing both sides by a. We get y over a equals x squared. Next step, Marcus.
Square root of both sides.
Root both sides. And then we get, and yes?
We get absolute value of x equals y over a.
Okay, why don't I need the absolute value right now? Sarah? Scott?
Because we know it's positive value.
How do you know?
Because it started out positive, it didn't start.
No? No? Eric? Because it's in the directions. I know that was a tough one. And I know that we're all a lot of math people, but once in a while you have to read. Yes, there's a little English involved. At a very basic level, it's called direction reading. So that's right where I'm at. I get my x equals, and we turn it around for what we're solving for. Yes. Shh.
Could you also say it's like rad y over a to get rid of the radical?
If you're going to read, otherwise, I'm not asking you to rationalize the denominator. I just want you to solve for it. If that were the case, it would be rad a over a. So it would be rad ya over both over the letter a. But they're not asking us to do this. So we're going to not rationalize. So next one. What do I need to do to get x to solve for x? Keenan. Divide both sides by a, and we get y over a equals rad x. Now what, Frank?
Now you want to square both sides.
And we get,
Y squared over a squared equals x.
and turn it around. That's it. That's it. That's all we have to do. Are you guys clear on this? Okay, let's try the next one. We're getting b alone. From our Pythagorean theorem, how about Julia? What would I do first? Subtract a squared. We can't just subtract an a, okay? Now what, Julia? Root both sides. B equals, nope, radical c minus a. That, remember inside there, guys, do not give me that this equals C minus A, because it doesn't. How do I factor that? If I factored it under the radical, what would that become?
It would become the quantity of C minus A times the quantity of C plus A.
There's not a perfect square in there that you can pull out a perfect square binomial. So it has to stay like that. We stop there. Do you understand that? Okay? Because C minus A times C minus A does not equal C squared minus A squared. You guys clear on that? Okay, how do we solve for A? Eric, start. Got it? Squaring both sides. And what do I end up with?
R squared equals A over pi.
Next step,
Multiply pi on both sides.
multiply pi on both sides. There we have it. Area equals pi r squared. Questions? That's it. Okay, I'll go back. I will go back. Okay. So, are there any other questions? Shh. Caitlin, did you just need to see it or do you have a question? All right, that is the lesson.